right, IM2 classes. We have more Pythagorean theorem today. So we are just going to be doing some example problems, other ways to use Pythagorean theorem other than determining side lengths. What we will be doing today is using Pythagorean theorem to determine if a given triangle is a right triangle or not. All right. So real simple. This should make sense if you think about it for just a minute. We have our side lengths. If the side lengths of a squared plus b squared is equal to b squared, then it is a right triangle. All right. So we're given all the side lengths. Yesterday we were given two of the side lengths. We're trying to find a third. Now we're given all the side lengths. If the a squared plus b squared is equal to c squared, it's a right triangle. But if it's not equal to c squared, it is not a right triangle. So let's get to it. Starting off, just like with any Pythagorean theorem problem, what you want to do is label the sides A, B, and C. So C is always the longest side. So here is the longest side. This down here would be the right angle if it is a right triangle. We always want to start off labeling the longest side C, and then the other two sides will be A and B. Those are interchangeable. All right. Then I'm going to plug those into the Pythagorean theorem. A squared plus b squared is equal to c squared. A, I have it labeled as 2 root 2 squared plus b is square root of 6 squared. And then c is square root of 14 squared. I'm going to do these two first. Square root of 6 squared. The root and the square just cancel each other out. So this is just 6. Square root of 6 squared is just 6. Same thing with 14. Square root of 14 squared is just 14. This one, when we have it in simplified radical form, this one is where it's a little bit trickier. We're going to use properties of exponents where I can each of these in here have an exponent of 1. And so this is 2 times the square root. I'm going to apply this exponent to both. That's just one of those properties of exponents we did a few weeks ago. So it's going to be 2 squared times the square root of 2 squared. All right. 2 squared is 4. Square root of 2 squared is 2. So 4 times 2 is 8. I'm going to bring down this rest of this. Right. Just bring this stuff down. So here we go. We get 8 plus 6 is 14, and that is in fact equal to 14, right? We want to, we're looking at here. It is 14. So what that means is that is, yes, check, right triangle. So let's look at this one, all right? Starting off again, you want to label the side lengths A, B, and C. C is always the longest side. So if you find what would be the right angle, this is going to be C. A and B are then interchangeable. It doesn't matter which one is which, as long as you got C as the longest side. So for here, again, I'm going to use Pythagorean theorem. A squared plus B squared is equal to C squared. I have A as square root of 101 squared. B is square root of 43. I squared C is 14 squared. So square root of 101 squared. Again, the root and the power just cancel each other out. You just get 101. Square root of 43 squared. The root and the power just cancel each other out. You just get 43. 14 squared is 196. So 101 plus 143, that is 144. And look at that. That is not equal. They are not equal. And so we are paying attention to that. So this is a no, not a right triangle. It is not a right triangle. So, and then here's the thing. Now you might be wondering, well, if it's not a right triangle, what kind of triangle is it? Well, we can use in Pythagorean theorem, the converse is what it's called, the converse of the Pythagorean theorem. We can determine if this is an acute triangle or an obtuse triangle. Let's look at another example here. So we're going to state if the triangle is obtuse or acute. So this is going to end up not being acute or not being a right triangle. So it's either going to be acute or obtuse. And what we're going to do is look at is a squared plus b squared greater than c squared. If that's the case, it's acute. If a squared plus b squared is less than c squared, that means it's obtuse. All right. So again, we're going to start off just like the other problems, label A, B, and C. C is the longest side. You just have to look at it, determine which is the longest side. A and B are then interchangeable. Right? So A squared plus B squared. I'm actually going to leave it blank here because we don't know what that is. And then there's C squared. I'll fill in the blank at the end, right? I'll put in a little line of separation. Right, but I'll fill in that blank at the end once we know which one it is. A is 2 root 10 squared plus B 8 squared, C 11 squared. Right. I'll do these easy ones first. 11 squared is 121. 8 squared is 64. So just like last time, you got to remember some invisible math here. The 2 has an exponent of 1. The square root of 10 has an exponent of 1. And using properties of exponents, each power gets multiplied by the 2 on the outside. So it's going to be 2 squared times square root of 10 squared. Right? So 2 squared is 4. Square root of 10 squared is 10. So this is 40 plus 64. And then 121, bring all this stuff down. 40 plus 164, that is 104. That side, I still have 121. So here, the C squared is bigger. All right. So what we're looking here, C squared is bigger. So we have this one. So this is an obtuse triangle, right? So what that means is this angle in here is bigger than 90. That's what that means. Let's look at one that's going to come out to acute. Spoiler alert, it's going to be acute. Same thing. Always start with labeling your triangle A, B, and C. C is always the longest side of the triangle. Always the longest side. A and B, then interchangeable. Then I'm going to substitute these values into the A, B, and C of the Pythagorean theorem. But again, because they're not going to be equal, so I'm just going to put a line of separation to keep the sides apart, and we'll fill in if it's greater than or less than here. So A is 12, so it'll be 12 squared. B is square root of 113 squared. And then C is square root of 254. And the square of that. 12 squared is 144. Plus square root of 113 squared. The root and the power cancel each other out, so that's just 113. Square root of 254 squared. The root and the power just cancel each other out, so this is 254. 144 plus 113, that is going to be 257, and then the 254, and this one is greater than, right? So if we go back, right, if it's greater than, that means it's acute, so this is an acute triangle. What that means is our angle up here, that would normally be the 90-degree angle, is less than 90. Acute triangle, all these angles are less than 90, right? Next thing that we are going to be doing is using Pythagorean theorem to help us find the area of a triangle. So first of all, quick reminder, the area of a triangle is the base times the height divided by 2. We did this last unit, just a little review on this. You've done this before. If you look at this, we have a right triangle where we're given a side length. And here, the hypotenuse here is not the base. So we can't multiply these two. We have to find this side length down at the bottom. I'm going to call this B for base. Sure. And that'll actually work out. First thing I'm going to do is label my sides C. So 9, the longest side is always the hypotenuse. And then it's going to be A. And I will leave the base B as B. Sure, why not? So I'm going to plug those into the Pythagorean theorem. A squared plus B squared is equal to C squared. A is 7. B is little b for the base. And C is 9. 7 squared is 49. Plus B squared is equal to 81. Subtract. Subtract 49 from both sides. Yeah, that cancels out. You get B squared is equal to, what is that? That's 52. And then I'm going to square root both sides. So you get B squared. Did not want that in green. So B, we do need to do a buddy system on this. B, so square root 52 splits into 2 times 26. 26 is 2 times 13. So I have a pair of 2s. So if you remember, for every pair, 1 goes on the outside of the radical, and then I have a 3 left on the inside. So it'll be 2 root 13. Okay. So now I can plug this stuff into the area. So the base is what I found here. Base is 2 root 13. Oh, you know what? I need to read directions. We're not doing simplified radical form. My bad. That's good practice though for us. When we're finding the area, I should have read these directions. We are rounding the intermediate values to the nearest tenth, and then round the finest. We're going to the tenth. We're doing decimal. So let me do the square root of 52. Is okay. Need a different calculator. Had a cheater calculator that gave me the answer in simplified radical form. I want decimal. So this is 7.2. So B is equal to 7.2. So here I can just plug this stuff in. B is 7.2. The height is 7. And then divided by 2. Again, we're getting the, just to be clear, I'm going to highlight some things. The height is this side here. So that's where this 7 is coming from, and we found the base. So 7.2 times 7 divided by 2 is 25.2. Oh. And there we go. There, we're done. One more example. This one is a little bit trickier. So we have the height of this triangle. We are missing part of the base. We have almost all the base, but we don't. We are missing just this part of the base. All right, so we need to find that. But if you look, we have a right triangle that we can use to find that base. So first thing I'm going to do, just focusing on that triangle that I have highlighted, I'm going to label the sides A, B, and C. So C is the longest side. I'll do the same thing. So I'm looking for, I'm going to call it X this time because it's not quite the whole base. All right, so A, B, and C. So here, using Pythagorean theorem, A squared plus B squared is equal to C squared. A is 3, B having that as X, C is 7. So 3 squared is 9 plus X squared is equal to 49. Solve for X. I need to subtract 9 from both sides. So that'll cancel out. I get X squared is equal to 40. And then I'm going to take the square root of both sides. And this time I'm going to follow the directions. And I am going to do that on the calculator. So square root of 40 comes out to 6.3. So this part here, I'm going to move some stuff around. this out of the way. So this is 6.3 from here, 6.3. So what I need to do now, I'm going to find the entire base. I don't need the A, B, and C anymore. So, oh, no, no, no. Oh, wow. Okay. Click a wrong button. It shuts down on me. Okay. Where's my, oh my, oh geez. That's what's the issue. Let's see, hopefully. Nope, not what I wanted. Okay, there we go. Sorry about that. Um, okay, where were we? Here. So I have, okay, it's all, can't change anything now. Okay. So I have this whole part is the base, all right, and then the three here, right, is going to be the height. So I'm going to use the area is equal to the base times the height divided by 2. The height is the easy one. That's just 3. The base, we need to add that together. So 6 plus 3 plus 3. So the base is the 6.3 that we found plus the 3. So it's going to be 9.3 for the base. And then divide that by 2. So 9.3 times 3 divided by 2. That comes out to 13.95, which rounds to 14.0. Said and done. All right. And that will do it for the lesson today. See you guys next time when we're talking about special right triangles.